So it's a great pleasure to be here opening this conference. The title of the conference, as Roger just said, is Expectational Coordination in the Stock Market. And when Roger told me that there was going to be this conference and invited me to speak, I was kind of excited because some recent research that I've been doing, I wanted to apply it to the stock market, to asset pricing, but hadn't done so yet. So this would be a great opportunity to do that. The title in the program, Rational Expectations Equilibria with Unknown Information Structures, is a description of this project. It's still at a somewhat preliminary stage. The ongoing new research is joint work with Dirk Bergerman and Thibaut Humann. So what I actually want to do in this talk, given the stage that we're at the research and also the context in which I'm giving it, is kind of spend a bit of my talk laying out a review, a biased review, but a way of thinking about the topic of this conference, different ways in which people have tried to relax the rational expectations assumption in the context of models of asset prices in the stock market, and in that context, introduce what we're going to suggest as a new way, in some sense, of relaxing the standard assumptions that were made that are going to get at some of the same issues and have interesting complementarities. Okay? So let me start with a review of approaches to relaxing, what we might think of as approaches to relaxing rational expectations assumptions in asset pricing models. On the website for the INEXC network, you can see a written statement and an interview with Roger in which he articulates the interest, a unifying theme that, rational expectations equilibria are an interesting benchmark, but it kind of assumes that expectations are coordinated, and it is a theme of this network is looking at different ways of relaxing the assumption is one way of thinking about it. Okay, so in this context, what I mean by rational expectations equilibria is, work that goes back 40, 50 years now, I guess, to thinking about asset prices when there's asymmetric information. So important work by Grossman, Radner, and others in the late 1970s thought about asset pricing when there are different beliefs in the economy generated by asymmetric information. So the standard type of assumptions that got made in that context is that there was asymmetric information about the state. We're going to assume that there is a price function that says in each state what a price is going to end up being. We assume that with asymmetric information, agents learn from prices, so they're able to condition on prices. And we maintain, implicitly or explicitly, the common prior assumption, that is, the assumption that everybody's beliefs are consistent. They could have come from a common belief about the world, updated according to some new information. Okay, so this framework was introduced. An important finding, due to Radner, I guess, is the argument that if you made these assumptions, they're rather strong assumptions, but if you made these assumptions, there was an implication, which is that you get generic revelation of information in rational expectations equilibria, which is going to make sure that there's a unique equilibrium. You're going to learn everything about the underlying asymmetric information. The common prior assumption, since it's going to be an important aspect of this talk, let me just say a little bit about the common prior assumption. The common prior assumption is an important question and an important assumption that you either make or don't make, and your reasons for making it or not making it are going to be important in wide areas of economics. And actually, it was kind of around this time that the importance of the common prior assumption became transparent to the profession. Why is that? Well, at some point, when we didn't have good ways of modeling asymmetric information, you just assumed that people had differences in beliefs and asked yourself, what are the consequences of those differences in beliefs? But once, around this time, the modeling of information, asymmetric information economics, took off, we had a way of thinking about asymmetric information, the idea that different people have observed different information, and that suggested a dichotomy between different ways in which differences in beliefs could arise. Okay? The modeling of asymmetric information suggested a way in which you could have people start out from a common prior assumption. You could imagine maybe this is a real or an imaginary world where everybody had the same beliefs and then they updated their information and that led to different beliefs. Or you could imagine a world where people had differences in beliefs and they're prepared to maintain their differences in beliefs even if it becomes common knowledge that they have differences in beliefs. Okay? This was an important distinction, especially important in the context of asset pricing models because of no trade theorems. No trade theorems clarified that if there weren't differences in prior beliefs, that is, differences in beliefs unexplained by information, if all differences in beliefs came from asymmetric information, then it couldn't explain why people would trade with each other. Okay? If beliefs came from a common prior assumption and you had just observed different information, then if someone was willing to trade with you at some price, that would reveal to you that the trade would not be beneficial for you. So think of the common prior assumption as a big issue floating around here. Okay? So let me survey what I'm going to try and classify, and actually I'll classify some of the talks in this conference a little crudely to think about if we think that we have rational expectations equilibria as a benchmark, think of different assumptions that we could, the conclusions seem strong, unrealistic. We can think of different assumptions that we can relax and how we can relax them. Of course, there's behavioral finance, which has been hugely successful, especially in the last 20 years. We might think of this as the most extreme relaxation, saying, we're going to, at least in the more extreme assumptions that are made in behavioral finance, it's kind of saying, well, let's give up on rationality a little bit and see what we can get, and that's very interesting research. But actually maintaining traditional economist assumption of rationality, you can still relax rational expectations assumption in lots of ways. One piece of behavioral finance, not all behavioral finance, but a significant chunk of behavioral finance, you could think of as giving psychological foundations for differences in prior beliefs that you're going to assume in asset pricing models. Okay, that is to say, we are going to assume that people have differences in beliefs that aren't explained by differences in information, but we have some compelling experimental psychological story for why we assume those differences in beliefs. And there is an old tradition of looking at pure heterogeneous prior beliefs and interests and their implications for asset pricing. Harrison and Krebs wrote a very classic paper in 1978, which after a long lag, there was a nice theoretical paper recently by Schenkman and Zhang, and in the last decade there's been lots of empirical work on this, at least from the title. Dumas' talk in this conference seems to belong in this category. Okay, the issue, if you relax the assumption of heterogeneous prior beliefs, an issue is always going to be, well, if we're not going to assume that differences in beliefs are explained by differences in information, a criticism is, well, if you allow that to happen, anything could happen. Okay, there are too many degrees of freedom. We should try and impose some restrictions. Well, again, I can sort of think about classifying different approaches that people have taken by thinking of different ways of disciplining them. Okay, so the talk of Mots-clés in a second and his joint work with Kurtz is kind of saying you could have heterogeneous beliefs, but heterogeneous beliefs could in fact be consistent with having an infinite amount of data if the world is complicated enough, as if there's not enough stationary structure. And that imposes a discipline. It says that your heterogeneous beliefs have to be consistent with an infinite data stream, but it turns out that that still allows for some heterogeneity. That's one response. I could think of learning in a crude kind of way as belonging to this category. It's saying we're going to think of people's beliefs coming through learning. Okay? As it happens, if people are learning about the world, that's where their beliefs come from. It won't be the case that at any point in time they will necessarily be derivable from an asymmetric infer model, but we have a theory of what the beliefs are and a relevant theory of what the beliefs are. Okay? There is also an aspect of heterogeneous prior beliefs in the research that Roger has done. I think some of this work on expectational coordination is going to be surveyed by Gabriel Degrange later in the conference. Roger has looked at what are the implications for asset prices of assuming that agents are rational. In fact, there's common knowledge of rationality. We're going to maintain the assumption of common knowledge of rationality and market clearing, but we're not going to impose that everybody has the same beliefs. Okay, so there is a sense in which there is heterogeneous prior beliefs in these theories, but it's saying that there's heterogeneous prior beliefs about prices, about these endogenous variables. I wrote actually in my thesis a few years ago now, as the introduction to my thesis, I wrote a review of different assumptions, different arguments that are made in favor of and against the common prior assumption as a modeling device in economic theory. It was eventually published in Economics and Philosophy. One of the arguments that I made there, it just occurred to me that it was relevant to this talk as I was preparing this talk. One of the arguments that I made there is that if you try and justify the common prior assumption by attempting to apply some philosophical theory that suggests that it makes sense to talk about objective probabilities out there, so you try to give a frequentist or a logical view of probabilities and where they come from, you can, that's an argument, that's a type of argument that people make. It's particularly difficult to make that argument, I argued, in the context of game theoretic settings where the beliefs concerned endogenous variables, okay, when it concerned the actions of players, okay, because you were writing a theory that was explaining their behavior, okay, there could be complete symmetry in the theory, so the idea that an objective theory could select one over the other when we were talking about beliefs over variables that are endogenous to your model is particularly troublesome in that case. Okay, and of course that applies to the work of Roger on expectational coordination. Okay, so you might think that's a particularly compelling context in which to allow for heterogeneous prior beliefs. Okay, so I think allowing for heterogeneous prior beliefs is interesting. However, I also think it is true that there hasn't been enough exploration of what can be explained by asymmetric information in asset markets. Okay, so while I think that examining the consequences of heterogeneous prior beliefs is important, there is a sense in which we don't know the limits of what can be explained, even if you maintain the common prior assumption. Okay, or at least that's an argument that I want to make today. Okay, so I think pursuing both things in parallel is a good thing to do. So I want to talk a little bit about what we can do here. What if we maintain the common prior assumption and see the limits of what can be explained by making richer assumptions? I mean, at the most basic level, models of asymmetric in asset pricing are not very well developed. And in particular, dynamic models of asset pricing with asymmetric information are not very well developed. Okay? Up until 10 years ago or so, there were 2, 3, not so many papers starting in the framework, in the classic framework of Cara normal economies, that was introduced by Grossman, and that looked at dynamic settings that allowed for a real richness of asymmetric information. Okay, people found ways to put asymmetric information into asset pricing models, but the ones that they tended to work with were naturally ones which were relatively tractable. Ones that were relatively tractable often worked because you made some assumption that got away from the richness of asymmetric information. Okay, as an example, if you assume that there's one agent who's always more informed than everybody else in the economy, okay, then you get a model of asset pricing with asymmetric information. But the existence of one guy who's always more informed than everybody else means that lots of basic results from symmetric asset pricing models keep surviving. So I would argue that a lot of dynamic asset pricing models with asymmetric information introduced asymmetric information in such a tamed way that you didn't get the full richness of what could be explained. Okay, there have been a few papers in the last few years pushing dynamic rational expectations models, maintaining a common prior assumption and seeing what you can explain with that. I wrote one paper with Frank Canal and Hyun Shin, but there are a bunch of others. On the other hand, Snell Banerjee, who's at Kellogg Finance Department, and some of his co-authors have also been looking at these dynamic rational expectations models and make the argument that within this class of models, there is some suggestion that you still need heterogeneous beliefs, okay, under the assumptions that they make. Okay, I'm not going to attempt to survey that work, but I do think that it's a good research agenda trying to say, you know, what can you do with asymmetric information? When do you need heterogeneous prior beliefs? Okay. I welcome questions, by the way. All right, another, you know, I'm trying to discuss these broad classes of theoretical ideas floating around. Another idea that arose, that was discussed in the context of rational expectations models, is the idea of endogenous uncertainty. Okay, in the basic models that, you know, going back to Radner and Grossman in the late 1970s, I mean, indeed, going back to the Arrow-Debreu model of general equilibrium with symmetric information, the idea that we're modeling uncertainty, that when we model uncertainty, we will take a state space as fixed, you know, plays an important role. The assumption is that as a modeler, you can fix in advance what the relevant state space is. And various authors, in various ways, argued that recognizing some form of endogenous uncertainty, that is, recognizing that the economy, the stock market, generated its own uncertainty, and that this should be taken into account in your theoretical modeling, was talked about in various ways. I'm from the UK originally. I just came from the UK, where Frank Hahn recently passed away. I think perhaps one of his last academic publications may have been a paper by Aaron Hahn in 1999 in JET, which was kind of making the case that, so here we had some seminal figures in the theory of general equilibrium, where we took the fixed state space as given by saying that this was one of the most important open horizons that you want to allow for endogenous uncertainty in this sense. Okay? So various people tried to allow for endogenous uncertainty in various ways. Okay, let me give a biased example. So in a paper that I have with Joycery Dada in 1997, we considered the question, you know, we thought about a economy, you know, in the spirit of the old Radner economies, And in this paper, we maintained the common prior assumption. Okay, we had asymmetric information, but we maintained the assumption that all beliefs could be derived from a common prior. We made the assumption of common knowledge of market clearing. But what we added in terms of that summary that I gave at the beginning of models of rational expectations equilibria, what we relaxed is the assumption that for each state there was a unique price. There's a deterministic mapping from states to prices. We allowed for the possibility that the agents maintaining the common prior assumption thought that there might be different prices in the states. So it's as if the auctioneer was randomizing in a state over different prices. Okay? And those beliefs had to be common, but then you could maintain all the other assumptions, common knowledge of market clearing, conditioning on prices, and all that. And you could get a richer set of stuff to happen. I mean, in particular, in settings where the Radner result on generic full revelation of information in rational expectations, this wasn't going to happen. Okay? So this is a way of thinking about endogenous uncertainty in the sense that it's saying, where is this randomization in prices coming from? Well, it wasn't in the original type space. It's saying there's some extra stuff coming in. So I could think of this as a way of allowing for endogenous uncertainty, maintaining the common prior assumption. Okay? All right. But in all this work that I just talked about, we've been maintaining when asymmetric information is modeled, the maintained assumption has been, certainly in my work with data and in all these asymmetric information models, of course, the classical way to model asymmetric information is to analyze what happens for some given information structure, okay, a known information structure. Okay, so people model information about asset markets by assuming that there's some known exogenous information structure out there. Okay? Now, of course, for the outside observer, the econometrician looking at the economy, the information structure is actually not one of the things about which we have the best possible data. Okay? So, conceptually, we kind of think this is an exogenous part of the system. But on the other hand, it's something that we don't necessarily observe very much. Okay? And there may be some interaction between the assumption that you know the information structure and that is the assumption that the information structure is given may be especially problematic in the context, if you want to model endogenous or price uncertainty, it might be a problem. Okay? So suppose it was the case, so the work, the new work that we're doing that I want to tell you about is about saying, suppose we maintain the assumption of common knowledge of rationality and market clearing, okay? We relax the assumption of common knowledge of the information structure. Okay, so we allow the information structure to be a free variable. We allow more variability on the information structure, but we maintain the common prior assumption. Okay? So what I'm going to be describing, although I'm not going to be giving it now, could be given formal epistemic foundations based on other work that we've done, that this is the set of assumptions that we're making. There's a paper a very nice paper by Elchanan, Ben Parath, and Aviad Heifetz that analyzes formally what are the consequences of assuming common knowledge of market clearing for a fixed information structure, but without the common prior assumption. Okay, and there's a sense in which this ties in closely with the work that Roger has done. You could think of it as an epistemic foundation for the modeling of expectation coordination in some of Roger's work. Okay, so this is going in a different direction. Okay, maintain the common prior assumption, relax common knowledge of the information structure. Okay, so before I tell you about asset pricing, let me tell you a little bit about the game theoretic work on which this new work on asset pricing is going to be based. But before I do that, let me pause and see if anybody has any questions. All right. So we're getting into this because we've been working for some time. My co-author Dirk Bergman and I have been working some time in in abstract game theoretic and more applied economic settings, but using game theoretic analysis, but not with prices, not with rational expectations equilibria. And I'm kind of going to be adapting. What you're going to be seeing is an adaptation of the arguments that we've done in this other context to asset pricing. Okay, so let me in one slide give you a little game theoretic background, and then I'll just set out the basic framework that I want to suggest to you. Okay, so here you'll see an analogy between, hopefully, the game theoretic exercise and the asset pricing exercise that I'm going to talk about. Suppose we want to characterize what can happen in all equilibria. Instead of fixing the information structure, we're going to allow the information structure to vary. So we want to know what's going to happen in a game for all possible information structures that the players might have, maintaining the common prior assumption, as we've been doing in this recent game theoretic work. Okay? So we have an epistemic result showing that doing this is equivalent to analyzing an incomplete information version of correlated equilibrium. Okay? In other words, it might sound difficult saying what could happen in every game for every possible information structure at once. That sounds messy, quantifying overall possible information structures. But actually, it's better behaved than working with a fixed information structure because you can show that it can be characterized as a particular incomplete information version of correlated equilibrium. We can show. Okay, and I'll show you a version of this in the asset pricing context. We'll sketch it at least. Okay, and again, the motivation here is that since an outside observer doesn't observe the information structure, maybe we should treat it as an unknown. And there are many useful things that you can do with this approach. One way we motivate it is it's a way to make robust predictions to say what could happen independent of the information structure, which is going to be a particularly relevant thing to do in the asset pricing context where you don't know exactly what the information structure is. Okay, in particular, relevant for this talk, we pursued this approach in detail in the context of games where players have linear best responses and normally distributed uncertainty. Continuum players. Okay, these are some particularly well-behaved games that are used in lots of applications, and we could analyze in detail what happens in that particular approach. Okay, that's going to be relevant for me here today because I'm going to want to apply this. I will be applying this to paranormal economies, settings where traders have constant absolute risk aversion, everything's normally distributed, so it'll be the same algebra in some sense in a rational expectations context. So this is like an adaptation of that logic. Okay, so to reiterate, what we're talking about here is having the information structure as a free floating variable, but maintaining the common prior assumption, equilibrium, and asymmetric information approach. Okay? So as I said, this is work in progress with Dirk Bergman and Thibaut Human. And you could apply this approach to any asset pricing environment that you want, okay? But in order to get going and in order to exploit the structure that we know about in the context of these linear normal games, let's apply it to a well-known one, the setting of in which Grossman and Stiglitz did some of their classic work on rational expectations equilibria. The version that we'll be talking about, I think, is due to Martin Helwig and Verrecchia looking at a continuum of agents with dispersed private information, constant absolute risk aversion, everything normally distributed. We're looking at a very classic asset pricing environment with this new set of assumptions. Okay? So here's the setup. Suppose you have a continuum of identical agents. This is going to be a static economy. I should have said that. Static economy. They have constant absolute risk aversion utility, so a utility function of this form where the parameter tau, 1 over the coefficient of constant absolute risk aversion, is sometimes called the risk tolerance. Okay? Let's assume that they're going to be trading an asset that has a normally distributed payoff theta. Okay? And in order to get around no trade theorems, there has to be a reason for people to trade with each other. Assume that in addition, there's a noisy supply of the asset, which has its own mean and variance. And for purposes of this talk, let me focus on the case where noise and payoffs are uncorrelated. Okay, so exogenous, so the asset payoff and the noisy supply are exogenous variables here that are going to be driving stuff. And the endogenous variables that I want to talk about is the price of the asset P, market price of the asset, and the demand of traders in the economy. Okay, and I'll represent this by looking at the demand of a representative. We're going to be maintaining symmetry. So we'll look at the demand of a representative trader. AI is his demand for the asset. Okay? So here's what our approach is. Here's how this approach that we developed in game theoretic settings is going to translate into this setting. Okay, suppose we just look for a multivariate normal distribution on these variables. Okay, the exogenous variables theta, eta are going to be distributed in this multivariate normal distribution according to the exogenous parameters that I specified. And let's just say that the price is going to be distributed as well, and I'll put in lots of correlation coefficients here. And the asset demand of an individual trader that I call AI is going to be similarly correlated with the other three variables. Okay, so the interpretation here is think of this distribution as generating the realized price, asset return, and eta. And then the distribution of the AIs here is the distribution in the population of traders' demands. Okay? So now, what have we got? We've got the exogenous parameters that we started with, the means and standard deviations of theta and eta. And we're trying to solve for some endogenous parameters, the means and standard deviations, and a whole slew of correlations. Okay? I'm not going to specify an information structure. I want to work directly with this thing, being agnostic on the information structure, and I will argue that it's equivalent to asking what could happen for all symmetric normal information structures that the agent might have observed. Okay? So what I want to do is take this description of this simple world and impose three kinds of restrictions. Okay? Not any of those correlations are going to work. Okay, there's actually, if things are normally distributed, there are going to be some restrictions. It has to be a legitimate variance-covariance matrix. Has to be positive semi-definite, so that's one restriction floating around. We want to impose market clearing on this distribution. Okay, what does imposing market clearing mean? It means that the distribution over the AIs, the average of the AIs must in fact be equal to eta. The average of the AIs in the population must be equal to eta. That's market clearing. And we must have rationality. I want the agents to be rational. I want to impose common knowledge of rationality. Well, there's a standard formula with Kara normal traders, which says that your demand for an asset is equal to the difference between your expectation of the return of that asset minus the mean of that asset times your risk tolerance divided by your variance of that asset. Okay? Now, your variance of the asset is going to be contingent on the price that you observe. We're in this asset pricing world where people can condition on prices, and the demand that you have. Conditioning on the demand that you have is a little unconventional here. Usually you would say condition on the information that you have. But I'm being agnostic about what information they have, but I know that they must have at least the information that generates that demand. Okay? So I'm just going to directly impose market clearing, taking an agnostic view on what the underlying information structure is. Okay? So if you do this, impose just these three restrictions, let me just, the algebra is relatively routine, okay? Market clearing is going to get rid of, let me not go through the algebra. Market clearing is going to get rid of a lot of variables, and we're going to be able to simplify the expression here. And then here's a bunch of algebra that tells you what happens if you satisfy all those restrictions. Okay? Let me just interpret the algebra. What the bottom line is that if you impose those restrictions, again, saying nothing about the information structure of the agents, just common knowledge of market clearing, traders are being rational, and it's a legitimate normal distribution. What are you going to conclude? Well, what we're going to end up with is two free variables, which is the correlation of the price with the asset return and the price with the noisy supply. Okay? There's going to be a bound on how correlated they can be. You can't be perfectly correlated with the fundamental and correlated with the supply, given that they're independent variables. So there'll be some limitation on how much correlation they can be. Okay? Of course, the variance of individual actions must be at least as great as the variance of supply. Okay? Because individual demand is just noise on top of the overall noisy supply of the asset. But the variance of the asset is going to be some function of other variables in the system. So this is going to be imposing some restrictions here. Just when you do those simple restrictions that I described, are going to impose some restrictions on what could be happening to these correlations. Okay? Once you fix the correlations, there is a two-dimensional array of things that could happen here. You are going to end up, we are also going to be able to pin down the mean and standard deviation of prices. Okay? So let me interpret these results. A key variable in this system is going to be what I'll call the effective risk tolerance. Okay, so take tau, which is the risk tolerance, a measure of, so the inverse of constant absolute risk aversion, so a measure of how much risk you're prepared to take on. Okay, divide through by the product of the standard deviation of the noisy supply and the standard deviation of theta. Okay, intuitively, if those things are less variable, then you're effectively more risk tolerant, okay, because there's less variation floating around. Okay, so that's going to be a key restriction. And then what turns out to be true is that if I look at the set of correlations between prices and noisy supply and prices and fundamentals that could arise, when effective risk tolerance is high, there are going to be very few restrictions on what can happen. Whereas when effective risk tolerance is low, there are going to be strong restrictions on what can happen. Okay, we can see it in a picture. Don't know how well you can see that. There is a green line that looks like this. Everything between this circle, quarter circle out here, and this green line here is the set of possible correlations between price and fundamentals on the y-axis, and correlations, which of course are negative, between price and noisy supply on the x-axis. So this big I here is the set of correlations that could happen. As the effective risk tolerance gets larger and larger, we're allowing for more and more stuff to happen for some information structure. Okay, on the other hand, as you let the effective risk tolerance become small, then whatever the information structure is, you're going to end up having to be on this circle. Okay, the intuition for that, I guess, is that with if there's very low risk tolerance, you're going to be pushed, whatever the original information structure is, you're always going to have to be pushed to the price being highly correlated either with supply or fundamentals or some combination of the two. Okay, we had an expression for price variance. Okay, you can ask the question, across all information structures that people might have, what is going to be the largest variance in prices that could arise? Okay, we're kind of going to get an intuitive answer, but it gives you a feel for this methodology. Okay, so what we can do is we can look and we can say, well, how do we maximize the variance of prices, which turns out to have this expression here, which correlations, which we're parameterizing the equilibria for, would we choose in order to maximize that? Okay, you do the algebra. It turns out that it's going to depend on, I didn't put it in here, but it's going to depend on, yes, okay, you can see it in here, okay? So we're going to get that either the variance of prices is going to be just equal to the variance of fundamentals, okay, or the variance of prices is going to be equal to the effective risk tolerance times, I guess, the variance is equal to the effective risk tolerance squared times the variance of fundamentals, okay? So which way you get the most variance is going to depend whether the effective risk tolerance is greater than 1 or less than 1, okay? The price variance is maximized by having the variance equal to the variance of fundamentals if there's high risk tolerance and equal to this expression if there's low risk tolerance. We solve these things saying this is what could happen for any information structure, but once we find a particular equilibrium that we're interested in, so like the case where we set this equal to -1 or this equal to 1, we can find the information structure that would have generated that. Okay, so this tells us that the price variance, the highest price variance that could arise for any information structure in this setting is what could arise if people knew theta perfectly. Okay? That is saying, if there's high risk tolerance, the most variance in prices comes from having people know theta perfectly. Okay? On the other hand, if there's low risk tolerance, then the highest variance comes from having them know nothing. Okay? And then the variance is being driven by the noisy supply. Okay? Yep.
So what happens to the correlation between the prices and the agent?
Yes. Sorry, I jumped over the arguments. That's going to drop out. Okay? Saying the correlation between the prices and the agent demand. That's actually, no, sorry, it doesn't drop out. But because trader demand is going to be a noisy version of total supply, these covariances have to be equal. So if you look at those expressions, that means that the covariance between prices and agent demand are going to be a function of the other variables that we have here. So that's the answer. It's implied by the other variables here.
So you can have price feedback. If that is positive, then we can also have behaviors which are like contrarian.
I don't think in this setting I can. That is, I have to have positive okay, I have to have negative correlation between demand and prices here. I don't know if that answers your question. But, you know, it's a simple set of assumptions, so this is kind of an illustrative setting. Okay, the other general exercise that I hinted, okay, that we do in the game theoretic analysis, if you ask what could happen for every information structure, if you solve for everything that happens in every information structure, you have a nice characterization without bothering to work through particular information structures. But then when you find a distribution that you're interested in, you can then reverse engineer and say, what's the exogenous information structure that would have gotten you there? Okay? And we can do that in this particular case too. Okay? One thing to highlight is the fact that there will be lots of different information structures that can get you there. Okay? So we can identify which information structure will generate which equilibrium. In general, there will be multiple information structures generating the same equilibrium. Okay? What you might think of as the most intuitive information structure is that you observe a signal of the fundamentals. Each agent observes a signal of the fundamentals. And suppose that it has noise, and the noise has a common component and an idiosyncratic component. Okay, so I could talk about a large common shock means that there's greater residual uncertainty. That is, the join of the player's information structures doesn't reveal that much about the state. Okay, we have 2 degrees of freedom here. If you could vary the amount of noise overall and how much of it is common and idiosyncratic, that's 2 degrees of freedom. So I can get all those equilibria that I described. They would result from doing the standard rational expectations equilibria analysis with those 2 degrees of freedom, and we would hit them all. Okay? But also, I could have made a different assumption. Suppose I did the standard rational expectations assumption, where I said, suppose people know nothing about the state, and suppose instead that the only signal that you observe is a noisy signal of supply. And you get no exogenous information about the state. If I then allowed the price, endogenous uncertainty, remember I mentioned endogenous uncertainty earlier, if I allowed the price to reveal information about the state that none of the agents have, I could also match all those equilibria. Okay? I have 1 degree of freedom, which is the variance in these signals about the noisy supply shock, which will allow me to control how much variance of the individual action is. But I have another degree of freedom that if we just have a price that's not necessarily measurable with respect to players' information, and that could reveal more or less information about theta, and players will condition on it, and with those 2 degrees of freedom, I can also hit all equilibria. I could also generate all equilibria. Okay, so let me conclude. So I've talked about relaxing the rational expectations assumption in asset pricing model. And talked about various assumptions that you could relax. The particular approach, I don't understand my slide here, the particular approach that I've just described to you is where we don't relax the common prior assumption, but shown that there's a close connection between relaxing deterministic price function, allowing endogenous uncertainty, and conducting analysis across information structures. If you do conduct analysis across information structures, it kind of subsumes all this analysis of endogenous uncertainty, and actually seems like quite a productive way to go, because Roger mentioned that we have some empirical talks here today. I'm pretty sure that empirical people don't actually know the information structure of agents in asset markets, so this might be a more productive assumption.